Hello everyone, welcome back to Math Learning with Shobita. I am back with a question from Group Theory which is asked in the Kset examination 2022-24. So the question, which of the following is a group? Option 1, the set of all matrices of the form A such that A belonging to Q, A not equal to 0 with respect to matrix multiplication. Option 2, set of all matrices of the form 2 by 2 matrices whose entries is A and A is belongs to Q, that is rational number A not equal to 0 with respect to matrix addition. Option 3, the set of all n by n matrices over Q with respect to matrix multiplication for n greater than or equal to 1. Option 4, the set of all integers modulo n with respect to multiplication modulo n. So we have to say which of the following is a group. How we can solve? Let us see. So what do you mean by a group? So first we see the definition of a group. So solution, a non-empty set G with a binary operation, a non-empty set G with binary operation with the binary operation star is a group if the following conditions are satisfied. Following conditions are satisfied. So what are the group axioms? So first one, closure property or closure axiom. So what it says, for all A comma B belonging to G implies A star B belongs to G. Okay. Option 2, associative law. For all A, B, C belongs to G, we must have A star B star C equal to A star B star C. Okay, this is the second property. Third one, existence of identity. Existence of identity. There exists an element E belongs to G such that A star E is equal to A is equal to E star A. This is true for all A belongs to G. Next, fourth one, existence of inverse. Existence of inverse. So corresponding to every A belongs to G, there exists A inverse belongs to G such that A star A inverse equal to A inverse star A is equal to identity. So here A inverse is called inverse of A. Okay. So if all these four conditions are satisfied by the given set, then we say that the set with the given binary operation is a group. Okay. So let us see which one is a group and which one is not a group. Here in option number 2, they have given this the set of all 2 by 2 matrices. The entries are rationals and A is not equal to 0. It is with respect to binary operation is here matrix addition. So for matrix addition, we know that the identity element is 0, 0, 0, 0, but they have given A is not equal to 0. So for this set, For this operation, the identity matrix 0 matrix does not belongs to this set. So this is not a group. So option 2 fails to be a group. Option 2 is not a group. Why? The reason is that because the identity element 0 matrix 0 0 0 0 does not belongs to the set G. Okay. Now what about the third option? Option 3. Option 3, they have given the set of all n cross n matrices over Q with respect to matrix multiplication. So here they are considering all n by n matrices. So this includes both singular matrices as well as non-singular matrices. So singular matrices have determinant 0, so they do not have inverse. So this set fails to be a group. Okay. So option 3 is also not a group. Also not a group. Because singular matrices do not have inverses. Singular matrices do not have inverses. Do not have inverse. So here the option in option 2 the fourth property fails, and in option 3 option 2 in third property fail, and in option 3 the existence of inverse property fails. So option 2 and option 3 are not group. Then what about option 4? The set of all integers modulo n with respect to multiplication modulo n. So they have given all integers, set of all integers, it includes 0 also. So 0 does not have inverse with respect to multiplication modulo n. So the given set is not a group. Option 4 is also not a group. It's also not a group because the element 0 does not have inverse. Okay, so this is not a group. So therefore the remaining option is option number 1, that is set of all matrices of the form A, where A is rational and A not equal to 0 with respect to matrix multiplication. It is a group. Even though it seems it is a singular matrix, it is a group. So how? We will see. So option 1 is true. How? Let us see. Let us verify that the given set G with respect to matrix multiplication is a group. So option 1, what is the first property? Closure property. So let any two elements A belongs to G and B belongs to G, where both A and B belongs to the set Q and A, B both are not equal to 0. Then there, with respect to matrix multiplication, so if you multiply A with B, so the product of two rational is also rational. So no, here there is no problem. A into B plus A into B, so 2AB. Similarly, you get 2AB, 2AB, 2AB. Since both AB not equal to 0, 2 into AB is also not equal to 0, and clearly 2AB belongs to Q. Therefore, the closure property is satisfied. Okay. Closure property is satisfied. Next property, associative. So associative also clearly holds. Associative property clearly holds. Why? Because rational numbers, these are all rational numbers, and rational numbers satisfies the associativity property. Next, third property. Third one is existence of identity element. So what will be the identity element? Any guesses? So clearly the element 1001, the identity element I2, will not be a identity element of this group, because here the entry 0 comes. So if it is entry 0 comes, then this does not belongs to the element of this, does not belongs to G. So here what will be the identity element? Let us check. Let x be the identity element. Then a into x, we should get it as a, the same element. Okay. So here after multiplication you will get 2ax, 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 2ax is equal to a. So equating, we get 2ax equal to a, or 2x is equal to 1, x is equal to 1 by 2. Therefore 1 by 2, 1 by 2, 1 by 2, 1 by 2 is the identity element. Identity element. And clearly 1 by 2, 1 by 2, 1 by 2, 1 by 2, their numbers are all rationals and belongs to G. 1 by 2 not equal to 0. So this is an element of G, and therefore it is the identity element. Then what will be the inverse? Whether inverse exists? Clearly the inverse exists. So what will be the inverse? Let us check. Now we have to get, let x be the inverse. Let x be the inverse element. Inverse element. Then a x, you should get the identity 1 by 2, 1 by 2, 1 by 2, 1 by 2. So here 2ax, 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 you should get 1 by 2, 1 by 2, 1 by 2, 1 by 2. Both are the elements of G. So here you will get 2x, ax equal to half. So ax will be equal to 1 by 4. So x will be 1 by 4a. Provided here a is not equal to 0. So they have given a not equal to 0 already. Therefore, clearly 1 by 4a is rational number. Therefore, 1 by 4a, 1 by 4a, 1 by 4a, 1 by 4a is the inverse of a. Okay. Hence, option 1 is true. Thank you friends. Please share and subscribe the channel.